Welcome to VW MOOC 25 and today's session. My name is Nellie Deutsch, and I'm coming to you from Toronto, Canada. Our presenters are both coming to us from Mexico. And our first presenter is INC, which is, I guess, stands for engineer. Is that correct, Ricardo? Yes, I see Christian is nodding. Ricardo Rivera Carrillo, and he is an animation and visual effects engineer who graduated in 2024. So that's not too long ago. Congratulations to you from the Polytechnic University of Santa Rosa. UPSRJ under the BIS educational model. His final project, creation of animated worlds, explored modeling, texturing, and rigging techniques in immersive realities. Since 2024, he has served as lead animator at the Department of Immersive Technologies, DTI, within the TramVet sector. His work focuses on creative development and visual design for projects involving virtual worlds, augmented, mixed, and extended reality. In addition to leading design and narrative direction, he contributes as a 3D modeler and integrates AI and advanced tools. He also coordinated the 2024 special edition of THE journal, enhancing the visibility of immersive technologies. I envy you for being an animator. I think that used to be one of my dreams. So today, it gives us wonderful pleasure to also have Dr. Christian Jonathan Angel Rueda. He has a Doctor of Educational Technology, a doctoral scholar. He graduated with honors for the thesis designing a didactic model to introduce teachers to the use of virtual worlds for educational purposes. He holds a master's in administration and consulting and a bachelor's in design and visual communication from UMQ and a specialization in educational research from CIIDET with honors. He's a postdoctoral researcher at UPSRJ, focusing on inclusive teaching and immersive 3D digital environments. He's a member of Mexico's National System of Researchers, SNI. He's a speaker at global events, including Virtual Educa, TechX, UAQ, and ASJ in Japan. He published on AI, ethics, virtual worlds, 3D immersive digital environments, 3D IDE, and XR-based education. And you can find his publications if you Google it on Google Scholar. And I highly suggest that you do. There's a lot of amazing work there. So thank you guys for joining us. And I can't wait for this session. Thank you everyone for being here with us.
Okay, thank you so much for that, Doctor. So, first, good morning, everyone. I am Ricardo Rivera Carrillo, and I am delighted to be joined by Dr. Christian in presenting our work entitled Designing Learning in 3D and Educator Animator Collaboration for Immersive Metrology Teaching. The subtitle, Innovating Dimensional Metrology Education Through Virtual Reality, encapsulated our innovate endeavor to transform educational practices in this field. We have from the Universidad Politécnica de Santa Rosa Jauregui in Mexico and the Instituto Tecnológico Metropolitano in Medellín, Colombia. So we are truly excited to share the insights from this collaborative project. This presentation delves into the synergy between a digital animator, as me, and educational technology, culminating in the development of an immersive virtual laboratory with Recroom. This environment not only replicates authentic laboratory settings, but also constructs interactive industrial scenarios, thereby foresting enchanted skills in dimensional metrology amongst students. To illustrate, consider how such virtual spaces can democratize access to specialist equipment, promoting inclusion and ethical considerations in education by ensuring that learners from diverse backgrounds can engage without geographical or research constraints. Let us proceed to the project overview.
Thank you, Ricardo, for introducing the presentation. And this project overview we have published one first article. We are publishing the idea is to publish three articles more with different ideas of the object studio. But well, uh, our initiative is informed by the article Dimensionando el Futuro, in Spanish, excuse me, Dimensionando el Futuro, Innovación en Metrología Dimensional a través de laboratorios de virtuales inmersivos, which I co-author alongside with Ricardo, Doctora Flora, Mercedes Trejo, Dr. Aaron Rodriguez, that are from our university, and Dr. Jairo Alonso Palacios and Diana Montoya, that are from ITM, from Medellin, Colombia, and engineer from our university that was yesterday with us, Ingeniero Martin, that is part of the programming process. We all of this project, we construct a virtual laboratory on the virtual world Recroom platform. Yes, with this Recroom, we make a simulation that I compare with another platforms. I like very much this Recroom because it's more easy to programming many things that we needed to this process. Um, with this compromising three distinct interactive rooms that we make it. The first mirrors the physical laboratory of the university that we are of Polytechnico Santa Rosa. The second focus on introduction, the use of the fixture and gate tool, and the third emulates an industrial environment for camshaft and related exercise. I like very much the third scenario because it's the reality of the situation that we can. It's more difficult to go with the students to a workstation that have this simulation than going in our own school and make this simulation in VR or with a smartphone or with a tablet or computer. The idea is that we can connect in different level of immersion from this process. This was a pilot with engineering students yielding results that demonstrate improved technical comprehension and practical competences. Ultimately, this methodology revolutionized metrology education by emphasizing experimental learning that transcends physical boundaries, aligned with principles of universal access to knowledge and ethical integration of the artificial intelligence driven immersive technologies. Engineer Ricardo should know elaborate on the technical context, please, in the next slide, please.
Thank you, Doctor. So for the project, I want to give you the context for that. So the dimensional metrology constitutes the scientific discipline concerned with pressure measurements, which is indispensable for quality assuring in engineering domains. For instance, it ensures the occurrences of camshafts in automotive components, thereby underpinning rentability in sectors such as automobility and aerospace industries. So the conventional educational paradigms encounter significant unless restricts access to laboratory owing to the high cost of equipment and inherent safety risks. So the challenge in this project is the visualizing integrate processes and the absence of environments conducive to repeatal and practices, which of the results in uneven learning outcomes. So the scholarly works such as that by Bryce Guzman or underscore these constraints envies a traditional laboratory equipment with vernier calipers and micrometers. Our ambition is to recreate the digitally incorporating ethical reflections and how virtual reality can enhance accessibility and inclusivity in technical education. So, and now hand over to Dr. Christian to discuss the role the virtual reality to the project. Please, Doctor.
Yes, thank you. Well, in this slide, the role of virtual reality is important, and the idea of VR connecting with the head of the immersion in total immersion, I like very much because when I was talking with the students, they said, "Oh my goodness, it's like feeling to be in the industry, and I'm here in the school." The total immersion from many persons say, "Oh my goodness," they look at in their smartphones and in the computer and say, "Yeah, it's good, perfect, exactly." But when they have to move, touch with her hands, clicking the buttons, and with a hand and looking in front of her, the elements was perfect. But virtual reality uh, surmounts these obstacles by offering a secure platform. That's so important for connecting the school with the industry. For practices in a life-like metrology scenario, having students' engagement through dynamic 3D interactions and facilitating global accessibility, thus mitigating shortages of physical resources. Like the empirical studies by I made in 2018 and the idea of Villarreal in 2016 indicate that VR augments knowledge retention through contextualized immersive experiences. Contrast this with traditional laboratories, which impose limitation on an access of incur subtraction costs. That's important. Yeah, yeah, yeah. When you look that in like our countries like Mexico, it's so important. Virtual reality uh, provides elevate engagement and adaptability from a humanistic perspective. This aligns with promotion universal access to knowledge, ensuring that immersive technologies like VR, augmented reality, X reality foster ethical educational practice and inclusion for all the learners. This occurs into our interdisciplinary collaboration. Okay, well, continue with the next slide, please, Ricardo.
Okay, thank you, Doctor. So in this slide, I want to talk about the interdisciplinary collaboration to the project because our endeavor merges expertise in 3D animation, all the parts of visual to the project, with pedagogical design. In my capacity as the animator, develop sorry, realistic 3D models and interactive mechanisms for object manipulation, guaranteeing the virtual environments are authentic and engaging. This technical foundation is crucial for simulating the real-world metrology tasks accurately, part of the virtual reality. So, in this part is so important to mention the visuals are so important to the project just to explain the concepts and the the object that you need to understand and learn by the metrology. Doctor, please.
Excuse me. It's in slide 6 or 5. 5? Yeah,
Five, five.
5. Excuse me. Uh, well, in this interdisciplinary collaboration, uh, as the educator, I ensure alignment with the metrology curriculum. I am not a metrology teacher, but I have talked with them, and I try to understand in this concept, in this context, how they teach with this in the real world, and try come here to ensure this process. But incorporating pedagogical strategies that cultivate both skills and conceptual understanding, the outcome is a suite of immersive laboratories that harmonize realism with educational objectives. As evidenced by we read Ayala Pesucci, who emphasized enhanced learning outcomes through such integrations. Consider the process of constructing a virtual laboratory while least mapping into the curriculum goals. Curriculum goals. Um, this collaboration explains a Marxist humanist approach, a prioritizing ethical reflection and digital inclusion in education. Please, Engineer Ricardo, will now address the theoretical framework, please.
Yeah, doctor. In this part, I want to talk now by the theoretical framework to the project. So the foundation of our project lies in immersive digital environments and technical pedagogy. Research such as the Dr. Rueda and Godinez demonstrates how 3D environments revolutionize learning via interactive, experimental, and modalities. For example, Alia Pesutili further illustrates the significance of virtual worlds in boosting engagement. So, by this project within metrology, specifically Oliveras and Santano and Brace Guzman, doctors validate the efficacy of digital integrations, and Villarreal positions the VR as a transformative pedagogical tool, envisaging a conceptual framework that incorporates immersion, education, and metrology, emphasizing ethical considerations in AI applications for the accessible knowledge dissemination. For example, if you use the AI, use the students do the homework, it's impossible to the students have the critical thinking to process the information. So, and doctor, please, will now outline the methodology for the project in this now slide.
Thank you. Okay, the methodology framework is important to understand this process of we're working with Colombia because we're brother like brothers in how to look the things, but in countries maybe we have to understand how they connect uh, this area of metrology and how our teachers understand this area of metrology. This is why the methodology framework is important to understand how we make it. We engineered 3 virtual rooms, this is important in this process, in Recroom, and evaluate them with students from our university. The methodology encompasses design phase that we use with Ricardo, the design phase, involving the creating a 3D model for metrology process, implementation, until in pilot sessions with VR training. Um, the difference when we took instrument of metrology in the real world and with the Red Room is different. But the sensation that we try to understand is how to be in the situation that it's not only the important of how to took the elements, the important is how to understand the process. That's the thing. Because in Recroom it's not in the real like our hands, it's like different hands, and in this case Ricardo have to understand how to took the elements for the animations, and that's so difficult in this process, but well, we make many pilot sessions with real training and look this difference. And the important thing in pedagogy is to understand the process, not the technique or the technical situations of how to touch the elements. Um, in the evaluation, utilization analysis survives and statistical analysis, the interaction refining elements based on feedback and dissemination of sharing findings broadly. This is important because when we analyze how they understand the concepts, because the important of these elements is to reasoning the process, reasoning the concepts, how to they will be in a practical situation, and that was the idea. Programming tools like response circuits and vector 3D creation underpin the interactions. Visualize a flow charts delineating these phases with association timelines, okay? Highlighting how this structured approach ensures ethical integration of immersive technologies in education, promoting reflection on inclusivity and universal access. It's important for our countries the universal access. If they cannot enter all in the same time with a VR, they can access and understand the interaction, and they connect with a VR, like connect with a smartphone, like they connect with a computer. Promotion, reflection of the inclusivity and universal access is so important. Please, Engineer Ricardo, will detail the rooms, commencing with room one, please, that the audience connect with our idea of the room one, room two, and room three, please.
Yes, Doctor, and thanks. So in this moment, I want to talk about the room 1, 2, and 3 for the project and explain what's the challenge of these rooms and what's the purpose of which one. So in the room 1, uh, faithfully replicates UPCRI laboratory. It's a laboratory that we have in the Universidad Politécnica Santa Rosa Jauregui, and to acclimate the students, so the students have the opportunity to stay in this place, in the real place, in the this real place. So the featuring of a 3D layout with points of interest along the perimeters and a central area reserved for prospective guides. For example, if you have a visual point to guide a person, is the most probably that you have the opportunity to to continue the away, you know. So the objects are rendered an interactive truth is the with the button is grabbable and is a property into the room 1. So the programming incorporates a response circuit and that's activated by our button, which governs position, rotation, and the target by two buttons. That is a connection that you can do it into the Recroom. That is a quaternion create and a vector 3D create. Uh, that suggests that the facility as a seamless bridge between physical and digital realms, adding transitions and underscoring the ethical value of VR in making specialist education more inclusive. That's the most important points to round 1. The virtual lab, the 3D layout, the programming that using the respawn and the transition, the most transitions, and the grabbable objects as a property. In the room 2, we have the other opportunities. I decided to the feature engage that is an object that we need to recreate and do a simulated into the VR. With designing zones for that using the component to display and create and measuring demonstrations by the students. What's the meaning of that? In the room two, you have the opportunity to, by the way using the layout and enables basic observations by as a student, you can the opportunity to see the object. What are the steps? Which are the steps for that? And the programming is streamlined to permit observation and manipulation by these objects in 3D virtual, who advocated guiding learners for conceptual grasp to practical execution, thereby enhancing accessibility in technical training through the immersive simulations. That's the part that we need to put attention, that the simplify the concepts in the visual helps for the students is so interesting, and is by the design that we need to put in this room. Just want to the opportunity to see the objects, and then in the room three is the important to demonstrate that you need to learn and understand the concept, that is using the metrology in the industrial simulation. So in this three room, well, in the room three, emulates an industrial factory setting for camshaft exercise, incorporating three conveyor bands and sector for students allocation, engineering for heightened immersive realms. The program employs a moving sequence. A bottom initiates the signals, random it generates values, execution enters switch router outputs, and the light orchestrates updates. That such designs prepare for the students for professional exigence in a risk-free manner, reflecting of the ethical imperative of using the HR technologies to promote safe, inclusive learning and inclusive learning environments. What's the meaning of that? So in this room, we need to the opportunity to recreate the simulation of the industry for the metrology practice. So it's important to have the points to consider, that the continuous movement of sequence and sequence and circuit programming, the students have the capacity to to put in attention and put the knowledge in practice. Is so important. This part is not interesting. The technical method is just important to learning and understand the exercise and the concept, and then doing practice. So the doctor Christian have the opportunity to explain and talk about the results for the project. Doctor, please.
Thank you, Ricardo. Okay, explain the three rooms. First room, the teacher explained the concept in general. The room two, make details of the concepts in the main details that they need to understand. And in the third room will be in the practice, like a simulation practice in the real world. Is three ideas for make one exercise being. And the results, okay. Well, the first results, not the main results. Mm, our findings revealed that 85% of the students report augmented comprehension through survives alone reduced error returns in VR tasks relative to traditional laboratories. Well, when we look, I will make a parenthesis here. When they try to make a simulation of the factory in the main school, the difference between the programming scenario that we make and the simulation that a teacher was making in the laboratory, the the main idea if in teams, if the first team understand how is looking in the diagramming the results, they say, ah, I understand it. And they say to the next team, this is a process. Press 1, 2, 3, 4, and you will be correct. And they say the others and the others and the others and all have, if the first team have the correct answer, all the teams have the correct answer because the students passed the answers. In this project, in this scenario in virtual world, the simulation make many variabilities. It's impossible, well, so impossible that one answer will be for all the teams because they have changing and changing and changing the answers. I like that. I like that for the results and for the for preparing our students in a real simulation for for this practice. Um, this respectable milieu fosters skills engagement. Uh, we corroborate that VR's superiority in education outcomes. Yes, in this practice, we can say in the third room that the VR is so effective for the students because it's difficult that they go to the industry and make this simulation because this is the real world. They practice in the real process and stopping for taking the elements that they have to analyze in metrology is difficult. Um, illustrating diminished errors and elevate comprehension in VR compared to conventional methods that I said right now, emphasizing the humanistic benefits of such technologies in advancing ethical inclusive access to knowledge. We can, with this technology, with this virtual world, not only Recroom, we can try to replicate these ideas with another virtual world. Why we use Recroom? Because how we can program the process with in programming how the process is more quickly than in another projects that we can need to understand many processes of programming. In this way, with the how to connect the elements for programming is more easy. And well, we have the main idea is that with this VR process, they connect like they say, okay, looks like animation, looks like a game, but the process is realistic, and we need the process to understand that the students. And they say we understand it. Period. In that point, and it will be the skills that we needed to understand, to reasoning the process. And well, we believe that, and we look at that in this process. We can continue with the next slide, please, with the challenge and solutions that we have in this first part of the project, please.
Yeah. So in these parts, we want to talk about the challenges and solutions for the project. Uh, I want to call it as a key challenges because the constraints of the VR platform, including processing limitations by the same platform, and the steep learning curve for the users. Sorry. The solutions entitled design, optimization, and comprehensive training provisionings. The interactive design for enchanting usability and the envisage a table in memory challenge their impacts and solution and resolutions, such as a refined programming which underscores the importance of ethical considerations in overcoming barriers to digital inclusion in education. And in this part, it's important to a mark. So yeah, to give a mark to the limitations in the platform because the platform have the opportunity to do a lot of things in 3D and you have the opportunity to create models inside to the platform. But it's important to understand the process limitations, and for that the learning curve for the users, because you are the investigator, you have the develop for the problem for the project. So for you is so easy to understand what's the way that the user have to consider to guide it. So, but when you have the opportunity to show the project to the other person, to the other student, it's important to to have the knowledge that if the 3D process and the 3D limitations is so is there in the project, you need to consider that by the curve for the users, and consider that the optimized VR designing to a real use in the VR directions. We want to talk about now in this slide about the future directions, and the Dr. Christian have the opportunity to explain that. Doctor, the microphone.
Thank you. Thank you. The challenge, I was thinking all the challenge we have. Yes, we decide Recroom because we look another platforms, but the challenge was so important of understanding between so perfection of another virtual world that we can make like a so realistic. The problem is when okay, so realistic, so interactive, but then the computer or the VR are so slow, have lags, the technical issues. As they say, oh my goodness, not all the computers we have to make the process, and we have 30 students, many students for one or three master computers. Okay, we low the process and go to low poly virtual worlds. Oh, so low poly like a virtual world or sandboxes like Minecraft. Okay, we can make that, but it's so low poly, and the interaction and idea of this process crashes in some parts. Okay, we have to like go into the middle. Okay, low poly but not biggest process. Okay, red room connected, but in red room we have such other situations because the form of connection in our movements in computer or in smartphones are hand. We can show the process hand. In VR is with your own hand, and it's more easy for understand the process. And we try to explain it in this three-person immersion with this computer or in these smartphones, uh, have a different way to understand the process. But when they connect in VR, oh, it's more easy because it's like put in the process. But well, this is the challenge that we have to hear understanding between the technique, between the technology, but the important is the didactic process. This is why we decided Recroom, because maybe in the process of using these technologies in another way, there are the useless of if to connect with a person in a quick moment, not have to make many movements to understand the further technology and then with a didactic. Maybe this is why we in this process we try to understand it or use it with Recroom. The future directions. Um, in perspective, development include incorporating audio, visual guides, expanding laboratories to encompass manufacturing and other disciplines, and forging collaboration with additional institutions. This is important. Imagine a roadmap, outline short-term engagement like guides and long-term expansions. promotion a vision of ethical artificial intelligence, because Recroom right now have they put in these 2 last weeks, like artificial intelligence to make models. In the same time, you say, well, I need here that model, bang. I need that element, bang. Or I have to, we're talking maybe with the students in not in the synchronous, asynchronous, it can be artificial intelligence with some books that we put it in the artificial intelligence and can connect with ideas, with a concept that when they are making the simulation. Okay, it's important, but we have to have a vision of ethical artificial integration, because they can do another thing that we don't like in the process of educational process. And in these immersive environments to ensure universal knowledge access and a reflection of the social impacts. How can change these elements in the social impact in this process, okay? Um Yeah, thank you. I look at the the Nelly look show that how is Rec Room is like a school in rooms of our simulations. This is why we look like rooms. Well, you can put Ricardo the last slide, please, the conclusion. And well, I will say the uh, here it's correct. It's correct. It's correct. Conclusion and Kate ways. I will say it once, and you can say the final part. Virtual reality laboratories are revolutionizing metrology education by delivering immersive accessibility experiences that transcend traditional limitations. Our educator animator partnership established a scalable frameworks yielding superior educational outcomes and align with humanistic values of inclusion and ethical technique use. The humanistic values is so important because the students understand that these were simulated and they have to go and work in a real world, but like humans. Uh, Please, the last ideas for finishing this, Ricardo.
Yeah, doctor. Uh, for us, this presentation is interesting to show you two parts of on a conclusion. Why? That reason is because the doctor had the opportunity to talk about the pedagogy situations, the vision by the students, and by my side, I can talk about the technical uses, a conclusion, and the methods that I can use it. So, by my part, in conclusion, from a technical standpoint, it equips learners with the tools to confront professional challenges in secure, interactive context. Envisage the 3 rooms, a laboratory replica as a tool-centric space, an industrial simulation, collective elevating metrology pedagogy through innovative VR applications. So what's the importance about that? Um, the two visions have the the opportunity to collaborate to construct this project. And for these presentations is interesting and is an opportunity to show you what's the result and what's the meaning about to work together. So these are part of the references that we used in this project, and we base it on the to construct the idea and the methodology for that. So thanks for
Thank
your attention.
you. Thank you, Ricardo. Dr. Nelly, I will show the scenario. I will look the red room. I will share my screen to show the scenario that we make it entire screen. And I will show in, here is, you look my scenario? You're looking my
Yes,
red
we
room?
see
Yeah.
it. Yeah, we
Ah,
see it.
perfect. Well, here is the idea. I like very much the idea of Red Room because it's like a university or like a school. This is my room, and all the things is from my room. I am here. I The thing that I don't like when I am in a computer is like I move like a robot. But in VR I look is for easy. I have my all my elements, and this is like Recroom, and it's the gym, dorms, rec center, paintball, and all the things that students like. When I want to go to my simulations, this is play. Well, here is in Spanish. What play with my library? I will show. This is the laboratory. It's a laboratory of metrology. We're changing things. Maybe the first rooms we're changing because we are putting the artificial intelligence, and we are putting all elements for the next semester. Well, with the next months, but I will show in first room, second room, and I like to show the third room. I will show in the. I think this is the scenario that we are talking about. The room three that I like very much. Uh, Maybe I try to look if there is working because Ricardo and Martin was changing something. But if you look, this is a scenario in the second room, third room. We have a plate. Oh, here are my glasses, and we use it. We have water. Here in this place, the teacher can write. We're in VR. Use it, and they can draw. Here. Excuse me. They can draw and uh, it's more difficult in. Excuse me, more difficult in the computer. But the teacher are have the glasses and use it very well. And the students come here. We reset. Oh, the industry. Tan, taran, taran. We have to put. I need the here. Let me see if I can touch. Come here. Let me see if reset. Here is. Taran. I have look at F. Taran, 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 taran. And then I have to come here. Let me see. We have to make a calibration. Let me see if I have to calibrate. F. Okay. And the values were over there. Let me see. I don't know if I do it well. Ah, ah, excuse me. I will say, debe tener un valor de 0. Tomar. Okay, and I have to measure this. Okay. Let me see if I put altura elevada. No, I don't care. Ah, if Martin is looking our presentation, please come here. I don't know if I put it well. This is a thing I have to, because in VR it's more easy to do it. This is one of my what the issues that we have it because this I throw the element. For me it's more easy to do it in the excuse me. I throw all the elements. For me, I look and do it with in VR. It's for me more easy for me. This is why
Yeah,
we
that's
have
because you're used to it. You're used to, but it depends, it all depends. You don't really need the VR headset. But is it open to the public? Can we come in and try things out?
uh, maybe in 2 weeks, in 2 months, we will put it to all the public. Right now, we are looking for the issues that we have to make the challenge, and well, because and you can look it. The idea is that all the things that I are put it with the instrument. Let me see if I can do it with reset. Let me see if I can. No, I can reset this. Let me see if I can reset. Here it
Just
is.
as you were working, how many hours do you spend here on average?
Well, with the students, we have chronometering like 30 minutes, doing the and they have to look all the elements and they have to check the different values, and they have to are checking all the values with the connection with these elements. This pass in 30 minutes with the first room, second room, 10 minutes, 10 minutes, like 1 hour with the 3 rooms with all the activities. 1 hour, and this is the activity, the final activity that they have to make it. And well, I don't know, is Martin? No, it's not Martin here, but well, it is the main idea. Let me see if I can do it well. Reset.
Will you have this in English as well? Will you have English
We
instructions?
try to first finish it because this is a experience for Colombia and Mexico. It will be in Spanish, but will be changing for English. Is correct, Ricardo?
Yeah, that's
They have.
correct. By the limitations for the platform, first we need to put attention by the dissemination of the Colombian Mexico. But in our plans, by the future, is change the language inside to the rooms to the English.
Wonderful, so that it could be used around the world. I think
Yeah.
this is
Yeah.
wonderful.
Thank you
Yeah,
so
the
much.
idea is to be open to all the teachers that make these elements of metrology, and with the measure on these elements. But no,
So keep me
I so
posted.
bad. I so bad in I so bad interacting interacting in a computer. Well, with
Yeah,
this,
because it's different. It's different,
yeah,
Yeah,
and you're
it's a
used to
different.
something else. But I'm sure that for most of us who don't have, headsets, this would be a
more
lot
easy.
easier.
Well, that's it. That's the main idea.
Thank you. Thank you so much.
Yeah.
Are there any questions? Andrea says that there's a Recroom Academy to learn how to use it. So we'll be able to use that.
Yeah,
Yeah.
It's, you have to practice to enter in this virtual world. I think I like Recroom. If you are new user, they put it in practicing. First in computer, you can practice in VR and something like that. But first you have to practice and checking the point that you need to be interacting in this virtual world, and then you can connect in another rooms and etc. etc.
Yeah.
But
No, it's lovely. Yes,
yeah,
Ricardo?
Well, in Recroom, if you see the tutorials, not only have the opportunity to see only a tutorial to do it step by step to put a button, if you have the possibility to understand the switches and the buttons and the connections to recreate, for example, the experience in the real life to into the VR and enjoyed it.
That's great. Can anybody create, or do you need to have a developer's account?
I show. Let me show. You can create um, with the platform into the platform of the virtual world, or I look that you say that if you have another you say that you can use Unity. You can use Unity
Yeah,
if you
yeah.
have a good process with Unity. In Unity, you need to have points
Stream.
in Recroom, like 30 points, like experiment user, to connect with Unity. If you don't have these points, you make things with the tools that are more easy. Difference with Unity is more professional. Let me show this difference. I can show the difference. Share. I will. Okay, here it is. You play. Here it is. You use the elements that are into. You can make it in VR. I more For me it's more easy making with VR the connections, and can you put the tab create, and you can create rooms. We have many rooms here.
For example, the
Because
respaldo, Doctor Abo. Respaldo
uh,
lab, for example, that.
este here is okay. This is the first room, but we can use creation. You can. No, let me see. Let me see. No, 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 no. Let me see my Sheila aquí. Use and put F, and I make elements in VR like modeling. It's more difficult here in my computer, but in VR is so easy. Well, and you can have many elements. We can select, transform. You can select and do things like this, and you not need to go to another platform. You can do it modeling here, making programming. Okay, here is skins. Here is the tool of like a roomie that we can use the artificial intelligence. And well, you have to pay to make things with this. Get energy. I had to pay $1, $2 per day. If you need to make modeling more easy, uh, let me see, room inventory. No, skins, paintball tools. Let me see.
No, Doctor,
You have
it's
assets.
part
Let
of
me
the
see,
maker pen.
Mochila,
It's
clothes.
part of the maker pen, using the maker pen.
Here is creation. If I use my dorm room, icon is magic. Let me change it. Don't save.
But for example, in this part, it's so easy to see the similar to model and create things inside to VR using only, for example, your PC as for example, other technical spaces. No, for example, Unity, Unreal, Maya, Blender, and so easy to do it if you don't have the a lot of opportunity to touch that type of software.
Yeah, this is I think accessible to more people because
Yeah,
you
yeah,
know, you don't have to know a lot like for Unity or Blender. You don't have to you know, install these because they take a lot of room on your computer. I mean,
yeah,
um,
yeah, yeah, yeah.
so it makes it more accessible to people who don't have, you know, a lot of room on their desktops, and it could be used on the phone. I'm just wondering, I guess you can also create on the phone. So it's exactly the same on the phone, right? It's
Yeah,
Yeah,
yeah, yeah. It's the same
so
of the phone and
that's
PC and VR.
perfect. Yeah, so that's perfect for most people because their phones are a lot faster than their internet on their desktops, on their
you can play.
computers.
You can play this Recroom in Nintendo Switch. It's multi-platform Nintendo Switch. I looked at you Nintendo.
Joystick?
Yes,
Yeah,
you
yeah,
can
with the joystick.
with the joysticks and you have Nintendo, and I remember that you have PlayStation. I don't remember, but are in different platforms.
Xbox. I think it goes with the Xbox.
Yeah, 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 yeah. I'm trying to remember exclusive.
Yeah, I think with Xbox because it goes with Azure with Microsoft.
Yeah, yeah,
Ah,
yeah.
this is the roomies. You have to change. Well, they have business. You need more
Yeah,
things.
of
You have
course.
to pay. You have to
Right,
pay.
right, right.
You have to pay. But I like very much the things that you can make here. The personalization. Here the create. Um, well, many things that you can do it and
Yeah.
connect with persons.
You know,
But
I
well,
think the rec room has changed. It wasn't always like this. I think they made a lot of changes since the beginning, and it looks a lot better. Looks great. So it's great for every age group. You know, it's for kids and for
Yeah.
adults and for teachers. Okay, so if you're an educator,
Yeah.
This is your chance to
And this is the way we can make.
upgrade your teaching.
Yeah, this is the way to is to make programming
Yeah.
with okay X's, and you can connect with
You mean
the
to understand
programmer
programming?
programming.
Yeah,
Yeah,
it's similar to a Scratch to connect block by block, and then it works.
You mean Scratch is still around?
Yeah.
Okay.
here is the button, and you can connect the button, the floor, and something like that. Well, is
Great,
that
great. This is wonderful. Thank you. Thank you for sharing that. I think this is probably one of the best. It's a lot better than a special, I can tell you that. And it has more features that are easier to use. So you can stop screen sharing. Thank you. Thank you for that. I think we've reached the hour. So Ricardo, can you stop screen sharing?
Okay, thank you.
There we go. All right. So thank you. Thank you so much for that. You did a wonderful job, Christian and Ricardo. And Ricardo, I wish you the very best. I guess you're doing your master's. Is that it?
yeah?
Yeah.
Okay, great. Thank you, Christian, and for bringing your student. And thank you for Ricardo, for teaching you so much, because I'm sure you're learning from your students as much as they're learning from you, right?
I am the
So,
theoretical, they am technique, and well, it's a good connection with
yeah,
my
good
my two
combination.
students.
Yeah, that's
Yeah,
how it should
Yeah,
be. That's how
it's
it should
opportunity
be.
to collaborate it.
Yes. Thank you. Thank you so much for this. And thank you, everyone, for joining us. Bye for now.
see you.
Thank you so much.